Chapter 12 is about economic growth. Chapter 12 has 5 sections. Do we need economic growth? Well, as long we have a growing world population, we need economic growth in order to prevent that well-being in terms of income per person goes down. Economic growth also helps to solve distributional conflicts. It's easier to give everybody a bigger piece of a pie when the pie is growing than when the pie remains the same size. Moreover, for poverty reduction in income terms, economic growth is helpful under conditions that indeed the poor benefit from growth. Social economics of growth focuses on the quality of growth rather than the quantity. It's concerned with inclusive growth and therefore includes a factor that is difficult to measure but important, a factor called social cohesion. This diagram shows you the share of total income that goes to labor in China. The remaining share goes to capital. You see that the share has declined from nearly 65% going to labor to only 50%. This diagram is a simplified picture for the efficiency of land redistribution. In the first pie chart, you see that small farmers own 25% of the land and big farmers 75%. With land redistribution, the small farmers now obtain 33% of all the land in the second pie chart, and the big landowners 67%. Now, what is interesting is that the second pie is bigger than the first pie, meaning with land redistribution to small farmers, total agricultural production increases. The institutional economics of growth has identified about 10 formal institutions that help growth, in particular through the state. That's why we refer to this situation of strong institutions for growth as the case of a developmental state. In institutional economics of growth, also informal institutions play a role, in particular pro-social norms. This gives us the institutional growth equation, in which economic growth depends on capital, but also the equality of the distribution of capital. Labor, human resources, that's the quality of labor, plus developmental institutions. Post-Keynesian growth theory is the most complex growth theory. That's why I will take you through a couple of examples. We have to distinguish, as we've done earlier, between Y, total income, and disposable income, that is Y minus T. So we can calculate the disposable income if we subtract the taxes from total income. That's what we do here. When we have the propensity to consume in autonomous consumption, we can calculate total consumption. Now, let's assume a tax reduction from 20% to 18%, meaning that the disposable income will go up, right? You have 2% more income to spend available. This also changes your consumption because consumption is out of disposable income. Remember that aggregate demand is consumption and investment in government expenditures and net export. So the aggregate demand will now increase by the amount that we calculated, the increase in consumption by 24 billion euro. Hence, a tax reduction from 20% to 18% stimulates aggregate demand. So, we had a 24 billion euro increase in aggregate demand. What does that mean for economic growth? Simply take the difference, 24 billion euro divided by the old level of GDP of 1500 is 0.02, multiplied by 100% is a 2% economic growth. Well, that's not bad, but we haven't included a multiplier effect yet. The multiplier, remember, is the effect of a stimulation on the economy with all the subsequent effects. So we have 24 billion euro as the effect on consumption. We divide that by 1 minus the propensity to consume. That was 0.8, remember? So we divide it by 1 minus 0.8, which is 0.2. So the result is 24 billion economic stimulation through consumption divided by 0.2 is 120 billion euro. This is the total effect, which is much bigger than 24. The effect on growth then is that we can add up the 120 billion to the 1500 billion. So we have now a total income of 1620. Subtract the old total income of 1500, multiply by 100%, and we have 7.5% economic growth. Well, that's quite good, of a tax reduction from 20% to 18%. So let's see what happens when we have a flat tax of 30%. 30% both for low incomes and for high incomes. The tax paid by capitalists is 30% times their high income, 75,000, gives you 25,000. The tax paid by labor is again 30% multiplied with their income of 30,000 gives you 9,000 per year. There's 80% laborers and hence 20% capital owners out of 1 million taxable citizens. So the capitalist income is 75,000 times 200,000 capitalists is 15 billion euro. 30,000 is labor income multiplied with 800,000 workers in the economy gives you 24 billion euro. So total income in the economy is 15 billion plus 24 billion is 39 billion euro. We can now also calculate total tax revenue for the government. It's 200,000 capitalists multiplied by the taxes that they pay and 800,000 workers multiplied by the taxes that they pay. Together, it's 5 billion plus 7.2 billion is 12.2 billion euro tax revenue. Now let's see what happens when we change the flat tax into a progressive tax. The laborers pay 28% rather than 30%, and the capital owners pay 50% of every euro they earn more than 30,000 euro. So the labor tax is 0.28 times 30,000 labor income is 8.400. The capital tax is this 8.400 plus on their additional income of 45,000, 50%. So that is 8.400 plus 22,500 together is 30,900 million euro. Remember the old tax revenue for the government was 12.2 billion euro. What is it now with progressive tax? Well, the labor tax is 8.400 times 800,000 workers is 6.72 billion euro. Capitalist tax is 30.900 billion times 200,000 capitalists is 6.18 billion. When we add it up, we get 12.9 billion euro. The earlier one was 12.2, so actually the new tax system, which is fairer, also brings more money into the coffins of the government, 12.9 billion. And note that I made a little error in writing this up in the book. It should be 13 billion euro rounded off. Now let's see what happens with aggregate demand. Let's take the flat tax 2 example of 18%. The rich pay 18% out of their 75,000 euro per year, which gives them a capitalist disposable income of 75,000 minus 13,500 is 61,500. The poor also pay 18%, it's a flat tax, out of their income, which is their tax payment of 5,400 then. And their disposable income is then 30,000 minus this 5,400 is 24,600. Let's now focus on the total consumption by the owners of capital and the laborers in the economy. For simplicity, we assume the same propensity to consume of 0.8 out of disposable income. So for the capital owners, we multiply the 0.8 with a disposable income of 61,500. We add up the 140 autonomous consumption, so the total is 49.340. And for the labor class, we multiply the 0.8 with a 24,600 plus 140. The total is 19.820. Again, billion in total. So we multiply each class consumption with the number of people in the class, 200,000 capitalists, 800,000 laborers, so it gives you a capitalist total consumption of 9.868 billion euro and a laborer's consumption of 15.856 billion euro. We simply add this up to get the total consumer expenditures in a country in a year. In this case, 25.724 billion euro. Let's now move from a flat tax to a progressive tax. The capitalist will pay 20% taxes, the laborers will pay 16% taxes. So the capitalist consumer expenditures and the labor consumer expenditures now consist of their own disposable incomes with different tax tariffs. The capitalist consumption is then 0.8 times 60,000 plus 140, and the laborer's one is again the 0.8 but now times 25.200 million euro plus the 140 million euro. So together we have in the aggregate 9.628 billion euro of the consumption of capitalists and 16.240 billion euro, that's the consumption of the laborers. Now we can compare the total consumer expenditures with a progressive tax and that of the flat tax. With a progressive tax it was 25.868 billion euro, and with a flat tax the difference is 144 million euro more. Again, we can plot this in a multiplier equation. So 144, that's the stimulation of aggregate demand with the progressive tax, divided by 1 minus the propensity to consume, so divided by 0.2, gives us 720 million euro. This is 1.8% of total income of 39 billion euro. So we have 1.8% economic growth thanks to a move from flat tax to progressive tax. I agree that the examples were a bit complex, but it shows you what endogenous growth means. The growth is from within the system, internal dynamics, for which we use the multiplier effect to calculate it. So back to endogenous growth. The key is that savings equal investments, and savings is what is left after you did your consumer expenditures out of your income. I is investment is the propensity to save out of profit income. That's the capitalist income. We used YK, but the standard notation is also R. So I divided by K is SR divided by K. Now remember, R over K is small r, that's the profit rate. And remember, I over K is small g, that's the growth rate. Now we have the post-Keynesian growth equation. Small g, that's the growth rate, equals SR, the propensity to save, multiplied with the profit rate. We distinguish between two growth strategies in post-Keynesian economics. Profit-led growth arises from high profit income, high R. The problem, obviously, is that workers don't earn a high income, so they have little income available to spend on consumer goods. The other strategy is wage-led growth. It's the reverse. Now capital income is low, that's R, but wage income is high. So there's lots of consumer demand, but not much investment in production. The solution to both constraints is the rest of the world. In the first case, when consumers don't have much money, you simply export to other countries to get foreign demand. In the second case, when there's high wages but not much investment, you simply invite foreign investors to invest in your country. And these two solutions are found in the global economy. The post-Keynesian growth equation then reads as follows. G, that's growth, is SR, propensity to save, times the profit rate, and that equals investment divided by capital. Finally, Neoclassical growth theory. Remember, Neoclassical economics is more concerned with the supply side than the demand side. So it's aggregate supply that is the driving force of growth through the aggregate production function of capital and labor. The assumption is decreasing returns, so you have to invest more and more to get the same size of growth. In the short run, you'll have productivity growth along the curve that I show you on the next slide. In the long run, technological innovations and more human capital will shift the production curve up. But this doesn't happen in cycles or any predictable way, but through shocks. This diagram shows you the aggregate production function in a neoclassical growth theory. The horizontal axis is capital over labor. The vertical axis is the output per worker. In the short run, we see moves along the curve, but you see you have to put in more and more capital in order to get the same amount of output per worker. In the long run, there is an escape from this decreasing returns, and that is innovation. So technology will shift the curve upwards. So this is the shift from the black to the red curve. This slide gives you an overview of growth policy in the neoclassical perspective, which comes down to neoliberal policies. Lower taxes in order to stimulate the profit income and hence investment, lower government expenditures, to give more space to the market. Also labor market flexibilization, privatization of companies, flexible exchange rates, deregulation, and trade liberalization. These policies in developing countries come under the label of structural adjustment policies. In the 1980s and 90s, they were implemented across the developing world with mixed results. The new growth theory is part of neoclassical economics, but it borrows from post-Keynesian theory. It looks at dynamics in the productivity growth of capital and labor. So it's not only the quantity that matters, but also the quality. And we see this in the new growth equation. It depends not only on capital and tech, and also on technology, not only on labor, but also on human resources. And what that leads to is shown in the diagram on the next slide. It's no longer decreasing returns, but also increasing returns. So here's the diagram for increasing returns, at least from the origin to point A. Then from point A to B, there is more or less constant returns. And then when we move beyond B to a point C that is not visible in this diagram, now the decreasing returns start kicking in again, like in the standard neoclassical growth theory.